Welcome to Tech, my name's Luke and I am going to blitz AZ-900 so that you can pass the exam in as little time as possible. Now, the AZ-900 it has essentially three main modules: describing the cloud, describing the architecture and describing the management. Now, each of these is then split into units. There's 3 in that one, 4 on that one, 4 on that one. So what we're doing is we've broken it out into this mind map and we're just going to blitz the concepts. Today we're first looking at describing cloud computing. Let's get into it. So what is cloud computing? Essentially it's just delivering compute services over the internet. You're watching this on a device right now. That device has a computer in it, or it is a computer. Now when you go and do cloud computing, what that actually means is you are accessing compute resources over the internet, meaning you are essentially using someone else's computer over an internet connection to access it, to get it to do stuff. Now, these computers, they're not just normally people's machines sitting in their house like yours. They're in these big massive data centers, which is just a big massive building or warehouse type of thing, which has a bunch of computers in it. And that's essentially it. Next up, shared responsibility model. So these three flavors are software as a service, platform as a service, infrastructure as a service. Infrastructure as a service, you are getting the infrastructure provided and that's it. So basically they're like, here's my computer, you can use it. With no operating system or anything, you then have to bring your own operating system on it or download one and blah blah blah. So you're now responsible for everything other than the computer itself. As in, if the power dies or something, that's Azure's responsibility or Microsoft, but everything else is pretty much yours. The other side of that is you get software as a service, which is where you get the entire software package to use as a service. Now that's everything up until the application, which then just means that all your data and stuff that's on it and who accesses it, that's then your responsibility, but they're giving you the software to then use. In the middle of that is platform as a service, which is kind of like halfway between each. There's a bit of a shared responsibility, which is branched over more parts here, as you can see. So the applications that are on the platform, that's kind of your responsibility, the networking controls, so who can come in and out, etc. And then there's stuff at the top, which is the access, so the accounts and identities of people that can access this stuff, the devices and the information and data on it, they're always your responsibility. So next up, let's look at cloud models. So you get the public cloud, private cloud, hybrid cloud. Public cloud is basically when you go into Azure and you want to just buy some resources to use, like a virtual machine or something, that's the public cloud. You're just going on, part of the public, boom, public access, you can do it. Private cloud, this is where you're not part of the public, so you can have private agreements on what you can use, what you can't use, this is mine, that's mine, blah, 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 right? Hybrid cloud, a mix of both, so you can have some of your stuff which is like agreed with Azure, this is mine, don't let anyone touch it, blah, 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 and then other stuff you're like, I don't really care, I'll use a bit of public. Now, say you wanted to use more than just Azure, you could use AWS or GCP, which are cloud platforms from Amazon and Google, respectively. Now, you can have some stuff from each of these. So, say, like, you know, your team already has an existing data analytics platform within Google. Then you can also use Azure if you really want to, if you have better costing or services that you want. And then that's called multi-cloud. Now you can use this thing called Azure Arc, which, as it says, is a bridge that extends the Azure platform to your environments. Now if we go to the Azure Arc website here, so Azure Arc, you can see that it says hybrid and multi-cloud management. So basically that's all you need to know for the fundamentals. There's also VMware solutions. VMware is a virtual machineware. So you have your physical machine, right? Now that physical machine is made up of resources. Virtual machine is virtualizing these resources into like a little bit, which is like its own machine. That's basically how you can think of it. And VMware is a popular way to use virtual machines or to enable virtual machines within your machine. And a VMware solution is Azure have capabilities to kind of extend that virtualization such that it's part of Azure. Basically meaning you can either quickly move it, so the virtual components that you're using, you can move them from your computer up into Azure, or you can use that and extend it up into Azure, because it's all virtualized anyway. So that's cloud models. Next up is we have to understand the consumption-based model. So the main thing you need to know for this really is CapEx versus OpEx. CapEx is capital expenditure, OpEx is operating expenditure. You can think of capital expenditure, CapEx, as investments. You go and you buy a computer. That's CapEx. You go and, I don't know, buy a new roof for your house. That's CapEx. But say you want a window cleaner to come. You want it to come every quarter, every month. That's OpEx. That's operational expenditure. In the same way with the cloud, the reason this consumption-based model is called that is because it's generally pay as you go in the cloud, right? I say generally because you can choose to not do this if you want to, do some private cloud stuff and have this specific set of resources for you. But in any case, consumption-based is you only pay for what you use, which means that you do this operational expenditure. You don't pay an entire year's worth of salary to the window cleaner. You pay every time he comes, right? Which is whenever you want him to be there. And so, basically, to leave on this, or to end on this, cloud computing is a way to rent compute power and storage from someone else's data center, which is just a computer. Welcome to InTech, my name is Luke, and I'm going to get you to pass the AZ-900 Azure Fundamentals exam as soon as possible. Last time we spoke about describing cloud computing, which was the first unit of the first module. We're going to cover the second unit of this first module, which is benefits. So let's zoom in and we'll blitz this. High availability. So each service line has an uptime guarantee as part of their SLA, which is a service line agreement. Basically, high availability means you want your services to be available as much as possible, highly available. Now, that just simply means that you want people to be able to access them all the time. And each service within Azure has a minimum guaranteed amount that it will be available. And most of the time, it's like 99.9999% of the time, which is a lot of the time. Next up, scalability. This is just adjusting to meet demands, and it's a benefit from the pay-as-you-go model. So if we talked about here in cloud computing, is that OpEx is essentially pay-as-you-go. Now, because you're only paying as you need it, when you have more customers coming to access your website and you now need to handle more of these customers, you can just scale up your website, pay for that, then scale it back down, and then you're only paying for this much. That's it. You get two different types of scaling. You get vertical scaling and you get horizontal scaling. Horizontal scaling would be like, my machine can't handle it, let me add another machine. Vertical scaling would be, my machine can't handle it, let me upgrade my machine. Essentially, that's it. Next up, reliability. So reliability is the ability of a system to recover from failures and continue to function. So high availability is just like, will it be there all the time? Reliability is, if it breaks, can we get it back up? So from the decentralized across-region design of the cloud, so the cloud is designed to be reliable because if something fails, it should be backed up somewhere else. Now you, as a customer, as a consumer, are partly responsible for this because you have to enable it often, right? Some services you don't have to, but sometimes you have to enable it to say that if this virtual machine breaks, I want it to be backed up in another region, and that will sort you out. So next up is predictability. So as I'd spoken about with scaling, for instance, you get performance prediction. So you can auto scale, you can do a thing called load balancing, which is basically, you can imagine if I had 5 computers and have one guy coming in, who's it go to? Doesn't matter. If I have 10 guys going in, it now matters because maybe one computer can only handle, so say 3. I can't give all 10 to one computer. So I'll try and give 2 to each to balance it out. Now, the next thing here is cost prediction. Now you can track in real time. That's one of the benefits of the cloud. And you can then leverage this data by using data analytics to then try and figure out when could I, predict spikes so that I can try and prepare for them. So maybe I don't have to pay for stuff to spin up all the time. I can try and predict it by spinning them up just beforehand, and blah, 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 right? Now you can also do this by using the pricing calculator within Microsoft, or you can use like total cost of ownership, which that's another type of price calculator. Next up is governance. So things like set templates, they can help you ensure deployed resources meet corporate standards and government regulatory requirements. For instance, you get this thing, policy as code, right? So you get Azure policies, which you can then review to make sure that you're up to date with the most recent regulations and guidelines. Additionally, you can update all your deployed resources to new standards as they change. Now, cloud-based auditing helps flag any resource that's out of compliance, for example, using policies. Now, security and governance, both of these have benefits when using software as a service. Because if we go back up here to the shared responsibility model, and so you can see here the operating system and network controls are managed by Microsoft. Now you can be pretty sure that the team at Microsoft who manage specific network controls or specific operating systems are probably more up to date with the security and governance than you are, right? Next up, for security, cloud services are well suited to handle things like DDoS attacks. DDoS is distributed denial of service, and what that means is essentially the services that you're trying to provide, say a website, are denied because some guy has made a bot, for instance, which sends out loads of requests to your website. So say your website can only handle 10 requests. This is completely unrealistic, but you get the gist. Say it can handle 10 requests. This bot will spoof a bot to make a bunch of 50 requests, because then suddenly as soon as it hits your computer, it's done. Well, cloud services have been made to work within the internet. As we said, it's just accessing someone's data center through the internet. So they're highly tuned to defend against attacks such as these. Now finally, we have manageability. We have manageability of the cloud, and we have manageability in the cloud. So of the cloud, it's things like automatically scaling resources as you need, deploying resources based on pre-configured templates, monitoring health of resources and automatically replacing failed resources, receiving automatic alerts based on configured metrics, right? So you can always be aware of performance in real time. So this is how you're managing the cloud, right? Or your cloud resources. For in the cloud, we have 4 different kinds: the portal, PowerShell, APIs, and CLI. So first is the web portal. This is what you'll use when you're accessing the URL. So most people will be interacting with Azure like this, just kind of noobs essentially, right? PowerShell, APIs, and CLI, these are programmatic ways to do it. So this is just using the website. These are using some degree of programming. So you get PowerShell, which is essentially like if you imagine a coding language built on top of a CLI. CLI basically being this here, like a command line. So CLI means command line interface, and this is just another way of interacting with your operating system, for example. So instead of using File Explorer, you can just open up this text-based view of your kind of operating system of your computer and interact with it that way. So PowerShell is like that, but plus a programming language. So you can download programming languages onto it, and then it's optimized for efficiency, etc. Right? And it's only on Windows. Next up, APIs, application programming interfaces. So this is where you'll write code which can then access Azure services via just writing a specific function or bit of code which calls it. So you can imagine, if you're very new to this, that the application has a doorway and you're coding to get into that doorway so that you can use the app. Finally, CLI, as we've spoken about, it is just a command line interface. It's just a way to interact via writing things on this command line. Welcome to InTech, my name's Luke, and I'm going to get you to pass the AZ-900 Azure Fundamentals exams as soon as possible. So in the previous episode, we covered the first module, first unit, first module, second unit, and now finally it's the first module, third unit, which is describing cloud services and types. So it's really just a continuation of our kind of shared responsibility, where we spoke about SaaS, PaaS, and IaaS. Briefly, what they are is AAS is as a service, so you get software as a service, SaaS, platform as a service, PaaS, infrastructure as a service, IaaS. And so what they are in short is IaaS is simply providing infrastructure as a service. So you can buy the use of infrastructure. It would be like me renting you my laptop. Software as a service would be like me letting you run your own Facebook as a service, right? And then platform as a service is the middle ground in there, right? My example that I give is GitHub. If you don't know what that is, it's a place to store code and to run code against that code. But basically they're just giving you the framework. So they're giving you essentially like a ring binder, and you still have to put the pages in, type of thing, right? And so essentially it's for running and maintaining applications as opposed to being an application in and of itself. So if we come all the way down here, describe these cloud service types. So your IaaS, this is optimized, or these are optimized for lift and shift migrations, which is essentially where you would have your on-prem data center, right? And you're wanting to basically move that into the cloud. And so instead of physically lifting the boxes and carrying them into someone else's data center, you're just like, right, I need this stuff, but in your cloud, exactly as it is. Because often what you should do if you're moving to the cloud is re-architect it, because the cloud offers things and services which you could leverage for often cost and security optimizations. They're also best for test and development environments. So for IaaS, you can just bring up some infrastructure and then you can run your code on it as you need and then tear it back down and then bring it back up, etc. Such as using things like Terraform, which we have videos about. They're best for test and dev. Next up, we have platform as a service. So we don't have to worry about licensing or patching. So like with Windows, right, you'd normally have to have a Windows license. If you're doing this infrastructure as a service, you would have to bring your own license, for example, using a lift and shift, right? And you would have to worry about patching the operating system to make sure it was up to date. Don't have to do that with PaaS. It's kind of like best for a development place, but without the infrastructure overhead, so without this, for example. It's also good for analytics or business intelligence, and that's where you're basically trying to mine through data. So you're looking through data to try and predict the future, or forecast sales, for example. Finally, we have SaaS. Software as a service. This is best for if you're wanting to use an app. For example, emails, Outlook, messaging apps, Teams, finance tracking, this different stuff. I put finance tracking in there because often in the exam it asks you about that. But anyway, that is describing the cloud service types, and that is us concluded the cloud concepts module. Welcome, I'm Luke at Cloud Consultant, and today it's Unit 4 of our study Cram for AZ-900, which is the Azure Fundamentals. Previously, we've covered cloud concepts, describe, benefits, and the service types. Today, we're moving on to Azure architecture. Specifically, we're going to talk about the core architecture of Azure. So, to start us off, what is Azure? Well, continually expanding set of cloud services. It's currently over 100. They help you meet current and future business challenges. So when you set up an Azure account, you'll see that there's a variety of layers here. So first you have the account which you create. An account can have multiple subscriptions, which are logically distinct parts. And within each of these subscriptions, you can have a bunch of resource groups, which can then have a bunch of resources. That's just the basic structure. Now to get an account, you can get it via Azure, via a Microsoft rep, or a Microsoft partner. You can also get a free account, so this is normally just via Azure, and you can get a normal free one or a student one. You can see here they have different service offerings. Essentially for a free account you get credits, which you can have for 30 days, it's like $200. 25 always free products, and free access to popular products for a year. And for the student one, you get certain services free for 12 months, credits for the 12 months, and some dev tools. And then for your development, you also have here a sandbox account, which is essentially an account where you can go on and run stuff and make stuff and do things without having to pay for it. You can get that, you can see that here, that's at that learn.microsoft.com. You can just follow the AZ-900 course, which I'll put in the description, you can see it there. So, that's the account architecture. The physical architecture, the infrastructure. So we have these different components here. We have regions, we have availability zones, and then we have this region pair concept. So an Azure region is a designated area. For instance, you get US West, US East, UK South, you get, a variety of regions, and these are a logical grouping of one or more availability zones. An availability zone you can think of it as a specific data center. We'll get onto it later, but you want multiple availability zones if you want to have a highly available application. And a region pair is just two regions which are paired together for disaster recovery purposes. So this AZ1 and AZ2, you might replicate stuff between here for high availability, but to go that extra step to really ensure, you want to then put it in another region. We'll get to it in a bit, but essentially it's so that then if this one fails, you get this one as backup. Now, Azure services that support AZs fall into either zonal, so they're stuck to a region, zone redundant, so they're across zones, or non-regional. Region pair, examples West US and East UK, it's for extensive outage, planned Azure updates, blah blah blah. Now you also get sovereign regions, so think of here as like China or the US government, and these are isolated for obvious reasons, compliance and legal. Now, final part of the core infrastructure is the Azure management infrastructure. So we vaguely talked about that up here, the account architecture, but we'll go over it a bit more depth here. So you have resource groups, which is essentially a group of resources. So it's an easy way, so if you were making an app, say, you could keep all of the resources for the app in one group. You could always manage them and find them that way. You can also then inherit, you can see here, actions or settings inherited by current and future resources, meaning then if you want someone to have access to the whole app stack, you just give them access to the resource group. And a resource group is one or more resources. Next up, you have your Azure account with these subscriptions. Now, subscriptions, they give you billing boundaries and access control boundaries. So you could have only a set number of people in dev, in test, and in production. That's a nice normal way to break up your subscriptions for companies. Finally, we have this thing called our management group. So you can see here that within a management group, you can have other management groups which can then have subscriptions, or you can have other subscriptions. So you can see it this later here. This is the management group. Subscription is a key. Now, why? To create a hierarchy that applies a policy or provide user access to multiple subscriptions. So here you could want one person in a specific region to have these subscriptions, another person in this one, and a way to logically group these together is to leverage this management group structure. Again, the same for here, you could want someone to have the whole of IT, so they could have this entire thing. Now, key facts that you might need to know for the exam: 10,000 management groups can be supported in a single directory. And a management group tree can support up to 6 levels in depth, excluding the root and the subscription. So in this example here, that's a 3 depth, that's the bottom and top, and 3 in between. And each group and sub can support only one parent, so you can only be in one here, for example. So there we go. That's core Azure infrastructure. Come back next time for compute and networking. Hope you enjoyed. So the first thing we have to know about compute and networking is what is a virtual machine. It is like a machine, like a laptop, but it's just virtual in that it's in the cloud. Now when you're creating one in the Azure portal, you can select the size, the disks, the networking, the operating system, etc. Now this provides infrastructure as a service because it's like getting a laptop but in the cloud, so it's infrastructure. Now these are optimized for lift and shift migrations, so if you were to then lift stuff from a data center, so for a company, and move it into the cloud, you can just create virtual machines in the cloud that are the same as the on-prem virtual machines. So they're ideal when you want total control over the operating system, running custom software or hosting configurations. So with virtual machines, you might want to scale them up if you have the demand. Now these can be scaled in two ways, using availability sets or scale sets. The main difference here is that a scale set, it's the same virtual machine scaled out, so it supports auto scaling. So when you want more than one to automatically come in if you have the demand, and then back down again. On the other side, availability sets, they can have a variety of different sizes, but because of this, there's no auto scaling support. Now also, availability sets, there's no AZ, which is availability zone support, it's only regional. For scale sets, regional or AZ. Now, within your availability set, you can have them within a fault domain and or an upgrade domain. So a fault domain is that your virtual machines within the scale set are within physically distinct parts such that if there was a fault in one, it wouldn't affect the other. So for instance, they could be plugged into different power sockets. Upgrade domain is more of a logical grouping, so they might all be in the same power socket, they might be within the same fault domain, but they're going to be upgraded at different times, such that if, say, Windows roll out an upgrade, it doesn't affect all of your virtual machines at once, that it maybe hits one of them, and that starts upgrading whilst your other ones run in the background. So, when to use your virtual machines during test and dev, when running apps, and when extending your data center, or during disaster recovery. Next up, we have virtual desktop, which is exactly what it sounds. Desktops that you can access virtually. So like this here, Windows, it's that, but you can access it globally, anywhere. And normally you would do that via HTTP or HTTPS, which is just up here. You would see it if we put it at the beginning. You can see that's just a protocol for the internet. It has an enhanced feature for security because it leverages Microsoft Entra ID, which is like a centralized security thing. You might have heard it called Active Directory. It's just a centralized way to manage access and security within Azure. Now, you can do MFA and RBAC, which is what enhances the security here. MFA, multi-factor authentication, would be like using your password and an authentication app. RBAC would be role-based access control, which is what it sounds like. You get assigned a role, and that role is the basis for access control. For example, if you have a team of developers, they'll have a specific role, a developer, or a specific subset, so a specific type of role. You only want them to get access to that one bit, give them that role. Additionally, the data and apps are separated from the local hardware. Because virtual desktop is like a virtualized abstraction, your data is not on that machine or on that laptop, it's somewhere else in the data center. Now with this, it lets you use Windows 10 or 11 Enterprise multi-session, the only Windows client-based OS that enables multiple concurrent users on a single VM. So it means that multiple people can access this virtual desktop at the same time. Now, next up, a bit of more of an abstraction from machines. We have containers. Now, you can think of containers as a virtual machine without the operating system. That means it's lightweight and designed to be created, scaled out, and stopped dynamically. One of the most popular container engines is Docker. Now, this is generally used to move something or to create a microservices architecture. Now, a monolithic architecture is one big app, for example. A microservices architecture is when you would have different containers or different apps which would be running different things such that they can be updated independently or they can be, changed, etc. Now, within Azure, we get container instance, container apps, and Kubernetes service. Container instance is the fastest and simplest way in Azure. It is a platform as a service. The container apps is an instance, but with benefits such as ability to incorporate load balancing and scaling it up. Again, that's platform as a service. Kubernetes, which is actually a container orchestration service. Now this helps, it says, manage fleets of containers across the life cycle. So you can imagine it here, you can run an instance, one container, see what happens. Here, you can scale that container out if you need it. Whereas with Kubernetes, it's much more complex and complicated that it can manage the orchestration, which is managing them essentially, loads of containers, scaling, and etc. So it's just like a big scaled out version of container apps. Now next up is functions. So this is where we're getting now into serverless stuff. Serverless meaning that you don't have to have specifically or explicitly selected the servers to run things on. You can just automatically, in the background, it deals with, say, networking. So where you may have to, in your virtual machine, you'll have to download Python and install stuff, blah, blah, blah. In functions, you could just add the Python code and it would run it, right? So it's event-driven, serverless compute. The benefits, you can code quickly, it runs in response to something. So if you have an Azure service, like a monitoring service, and when it notices a specific event, it will then trigger this function to run. Now, it scales automatically, it's pay-as-you-go for the CPU that it uses, and it is stateless by default, but it can become stateful. So durable functions using context. So state is essentially, stateless means no memory, stateful means memory. And so you can make your function have memory, like remembering stuff, if you use context. Now, for apps themselves, here are our app hosting options. So we can use Azure App Service for web apps, mobile apps, logic apps, and API apps. Now we can link in directly from the code, so using, for instance, Azure DevOps repos or GitHub. It allows a variety of coding languages to run. Here's just an example of some. And it always allows for Windows or Linux based apps. And so basically for here, you have code and you inject it into Azure App Service via connecting it, such as from GitHub, and it runs your app or hosts your app. Hi, I'm Luke at Cloud Consultant and welcome to part 2 of Compute Networking, which is unit 4 of our AZ-900 Azure Fundamentals Cram. So in part 1 of this, we talked about the different compute options. We're now going to look at networking, which is VNets, including VPNs and ExpressRoute, and then DNS. So, first things first, what's a virtual network? It is what it sounds like. It is a virtualized networking. So, we have a bunch of machines connected to each other by cables. Well, in the cloud, this is all virtualized, so they're not just one machine connected by one cable. It's more complicated than that, but logically, it's just like that. It's like having a bunch of virtual machines that have cables to each other, right? Now, why do we use them? For isolation and segmentation. So we have our original VNet that we'll create, and then we have subnets within that, so sub-networks. But the one important thing to realise here is that private IP ranges can be used for VNets and subnets. So a public IP is the IP address that makes your computer or your service publicly available and accessible via the internet. If you have private IPs, then you don't need a globally unique IP because you don't need the internet to come and get you. So, communication. How do you connect with and to and between virtual networks? So, first is the internet. This here is a public IP icon. Oh, there's the cat. So, you can access a virtual network via the internet if you use a public IP. Next up, Azure services. So some Azure services will automatically route, for example, virtual machines in Kubernetes. Other ones you have to use service endpoints, such as like SQL databases and storage accounts. Now, if you want to communicate on-prem, you get two options, ExpressRoute and VPN. ExpressRoute is essentially a direct cable between your premises, your on-prem, and Azure. VPN, on the other hand, goes over the internet, so you can think of the security considerations there, and it can be either a site-to-site VPN or a point-to-site VPN. A site-to-site VPN is from the actual site itself, so say from your data center, then uses a tunnel straight to Azure, right? Whereas a point-to-site would use a point, not a site, so a point would be like a laptop, and for that, there's other ways that we can tunnel it through. You don't need to know the intricacies for AZ-900. So within ExpressRoute here, we have a couple of things that you can have a quick read. I'll briefly say them out loud. Security considerations, it's never over the internet. The features and benefits, connectivity to Microsoft Cloud Services, global connectivity, dynamic routing via BGP, which is a protocol, and it's built-in redundancy at every peer and location. So how do we connect to Azure via ExpressRoute? That's where we have these connectivity models. Number one, co-location at a cloud exchange. Cloud exchange is an exchange where cloud traffic is routed through. If you can co-locate your physical servers at this exchange, you can then request a virtual cross-connect to get that routed towards Azure. Now that way you don't have to go over the internet. Next is point-to-point Ethernet, so just a cable between you and Azure. Then any-to-any networks, so if you already have a wide area network, which is a WAN, W-A-N here, you can integrate that into Azure, right? Finally, directly from ExpressRoute sites. So this is kind of like point-to-point, except point-to-point is usually provided by some third party, whereas directly from ExpressRoute is exactly that. It is directly from Azure. Now, next, within VPN, you recall we had this site-to-site and point-to-site. Now, what is a VPN? It uses an encrypted tunnel within another network. Right, you might kicked it. And so to connect to your virtual network via a VPN, you require a VPN gateway. Now, because that's a way to connect to your virtual network, you can only have one per VNet, and it goes in its own subnet. Now, the VPN types that we have are policy-based and route-based. You can read more about it here, but essentially, policy-based, you can imagine that they're checking every single person that comes through, so every single packet, which is the way that internet is routed and passed across the internet is through packets, which are like small chunks, and each of these chunks will have a specific where it's coming from, where it's going to, what protocol it's using, essentially, and then the information. So for each of these, it statically looks at the specific packet and is like, right, where is this going to go? Whereas route-based, it's much more abstracted, and because of that, it's more resilient to topology changes such as creation of new subnets, because if things are changed, it doesn't have to re-look at every single packet and update all these rules. It kind of dynamically moves with it, right? So instead of manually setting policies for each IP, the system uses normal routing to send traffic through the relevant tunnels, and then encryption happens automatically within these tunnels. So instead of encrypting every single guy that comes in, it's like, right, you go into that tunnel, you go into that tunnel. Now, high availability scenarios, so this is where you want to have like a failover VPN gateway. So you don't want just one in case something goes wrong. You want this high availability. So we have active standby, which is the default. During this failover, it will be a few seconds if it's planned, or if it's not planned, it's supposed to be less than 90 seconds, but there is no agreed SLA for that. Active standby means you deploy two, one's active, one's just on standby waiting in case there's a failure. Now, you also get active-active, where both of these guys are active, right? And so this is leveraging this BGP protocol that we previously talked about. And because we have two and they're active, there's an IP address for each of them, with separate tunnels from on-site to each, so it's like two access points. They can also be used as an express route failover, so if your direct connection doesn't work, you can then use the VPN. We can also have zone redundant gateways, which are automatic for express routes and VPN gateways in regions that support availability zones, so multiple. And these gateways require different gateway stock keeping units, SKUs, and use standard public IP addresses instead of basic public IP addresses. Now, this is one to recall for the exam between standard and basic. You think of basic as the one provided by the internet, right? So you have a specific public IP and it has no extra features. Standard is where it has some of the extra features provided by Azure. Now, next up, if we scroll up here, we have VNets. So VNets to VNets. Now, this is called peering, and it goes over the Microsoft backbone, so over the Azure backbone, meaning it's not across the internet. And now, user-defined routes allow you to control routing between these subnets and VNets, so between subnets within different VNets to talk to one another. So, within virtual networking, what happens with the network traffic? Now, it can be filtered and it can be routed. So, filtering, normally, is between either an NSG, which is a network security group, or a network virtual appliance. Now, NSG allows or blocks traffic based on inbound and outbound security rules, which include your IP, your port and protocol. So basically you say allow from this inbound specific location this, or block from this outbound, so don't let this specific message leave the virtual network. So if it was something like you don't want anything to do with the internet, you want your VNet to be fully private, right? You would block traffic out of the network that goes to the internet and in. Now, network virtual appliances, instead, these are actually just specialised virtual machines. For example, you get firewall or WAN optimization. Now, routing, you get that via a routing table, so a route table where you go, if it's coming from here and it's going here, this is the direction it needs to go in. And this is enabled using the Border Gateway Protocol. So this works with Azure VPN gateways, Azure Route Server, or Azure Express Route to propagate on-prem BGP routes to Azure Virtual Networks. Now, DNS, Domain Name System. So this is essentially your phone book for the internet. If you have a name, it then gives you the IP address. This is a hosting service for DNS domains provided by Azure. The benefits: reliability and performance, so anycast networking, so the closest available DNS server answers each query. Security is based on Azure Resource Manager, so it uses RBAC, activity logs, resource locking, etc. Ease of use, because it's just directly in the portal. Customizable VNets with private domains. And finally, alias records, which is like if you had google.com, an alias would be test.google.com, dev.google.com. Now these alias records, these are normally used for resources such as traffic manager profiles or CDN endpoint, which is a content delivery network. So instead of being like the main source, you can have sub-sources that you can access instead. So if you were like on Netflix, instead of going to netflix.com, the actual big netflix.com, you can go to a CDN which holds some of Netflix's data, especially stuff that's being used right now. So for example, when the TV show You comes out, right, they will have all of the episodes of You in this CDN, which is in the UK, because then instead of having to go all the way to America to get the You episodes, you can just stream it from the UK CDN, and that will maybe be called uk.netflix.com. So if you have an alias for a service instance, for example CDN, right, if you have a CDN service instance, this service instance is associated with an IP address, and because the alias points to the service instance, if the underlying IP address changes, then it's all good and it doesn't have to worry about it. Now that is us for compute and networking. How you doing? It's Luke at Cloud Consultant, and today it is Unit 5 of our AZ-900 fundamentals. So in the first few episodes we covered cloud concepts, you can check this all in the description. Then we covered the core architecture of Azure, compute and networking, and now Unit 5, storage. So first things first, you have to know, what is a storage account? A storage account is a unified place for all of your storage needs within Azure. Now to access your storage account, it's via HTTP or HTTPS, meaning it's just via the internet, via a web browser for example, and it is a global service. Now you get a variety of types of storage that you can hold within your storage account. For example, standard general purpose V2, which in here you can hold either files, queues, tables, or blob storage. Blob storage just means binary large object, which is essentially, a binary is what you would get at the end if you've had code and you've compiled it. So you had a .python file, .py, and then you've compiled that and turned that into code which you would run on a computer. For example, like down here, one of these icons, that's actually a binary that's running, not Python as such normally, right? And that's a blob. Now you get premium file shares. Now within your storage account you'll get two types of blobs. You'll get your page blobs and your block blobs. So your premium page blobs, binary large objects, and your block ones, a page would be more akin to something like a disk, like a hard drive, right? Whereas a block would be more like some specific unstructured chunk of data. For example, a file or an image or an MP3, something like that. Now, the letters here you can see at the end we'll cover later, but essentially RS means redundant storage. So your standard general purpose V2 can go in either LRS, ZRS, which means locational, or zonal, or any of the other ones. So anything that's redundancy, it can use. Whereas your premium ones, these can either use locally, that's it. So these letters here after them, RS, blah blah blah, star just meaning all, so all redundancy storage, whereas here it's locally redundant or zonal redundant storage. We'll get to what they mean in a minute, but really what you just need to remember is for standard general purpose, the redundancy can be anywhere across the world, blah blah blah. For page blobs, it's only local, and for premium file shares and premium block, it's LRS or ZRS. Now, if you want to connect to any of these, you normally would use the HTTPS, and this would be what you're going to type into your URL, which will be the storage account name .theservice.core.windows.net. Now remember that for the exam, core Windows net. And the service would be blob, DFS, file, queue, or table. So now we've looked at storage account, let's explicitly look at the storage services. So we have these ones here, but to be more specific, we have files, which is a fully managed file share, accessible via SMB or NFS, or Azure Storage REST API. Now SMB and NFS are industry standards for file shares, that's as protocols. REST API, that's essentially, an API is like a doorway to another computer, another bit of code, right? And a REST one, the way to imagine it is essentially it just waits for you to ask it something, then it'll give you it back. So it rests until you give it something. The key benefits: shared access, scripting and tooling, and familiar programmability. So if you're used to file shares, you already kind of know what to do here. Next up we have queues. Now the queue size is the SA size, the storage account size, because a queue can be as long as you want because it's just an abstraction, it just has to fit in the storage account. And one message is 64 kilobits. Kilobytes. I'll put a capital B. Let me see. Kilobytes. Yes, so kilobytes. Use case: if you have a backlog of work to process asynchronously. So if you have a bunch of people who, were messaging you, each one of those is going to be processed asynchronously, so it's not, at the same time, it's just one after another, processing it through, that kind of thing. Ticket sales, for example. Disks, that's just like a hard drive, a hard disk. Tables, so this is for no SQL, so this is structured but non-relational. What that means is it's in a table format, but items in that table, so columns, don't point to other tables for more data. It's just contained in here. Now this accepts calls from outside Azure, so remember that you can write a code which then goes and interacts with this tables. Finally, blob, scalable object storage, for example text or binary files. Use cases: serving images, docs to a browser, storing files for distributed access, streaming, backing up data, data for analysis, etc. Now here we have our Azure Blob storage tiers. So a hot tier, you're going to access it within the next 30 days, right? So it doesn't go more than like 28 days without being accessed. Cool tier is more than 30 days, so you don't access it every month, say, but you access it more than every 90. Cold is more than 90 but less than 180, and archive is you only access it like once a year. At the account level, you can specify that you want storage accounts or blobs to be created within this hot or cool tier, but you can't set that the entire account will have blobs always at the cold or archive tier, but they can always be at hot or cool by default. So that's blobs. Next up, within storage, let's look at Azure Migrate. This is for data movement. So Azure Migrate is what it sounds like. You're migrating data from an on-prem data center, say, into the cloud. So unified migration platform with integrated tools. It has tools for discovery and assessment, so finding the servers that it needs to bring them up, migrating these servers up into the cloud, pretty much with like a click of a few buttons. It then has a data migration assistant. Now this is for SQL, and it will check features and possible problems that you're going to encounter when you go into the next stage, which is DB migration service. So server migration is like the VM. Database is actually when you're then going to be moving the database. So not literally just the server and the disk, but then the database that it's accessing. And for that they have database migration service for SQL. They then have an app service migration assistant. So if you have like an on-prem PHP or .NET app, it will then see if it can bring it up and use our app hosting service, which if you recall from the previous video, this here, so it will try and put you into here instead of having to spin up a virtual machine. So if we come back here, finally we have Data Box, which is a physical box. You think about it like a hard drive, right, with 80 terabytes. And for this you can either use it to send stuff into Azure, or you can get it to get things out of Azure, so your data for data movement. Finally, for storage we have file movement. 3 ways to manage moving files: AZ copy, so this is like a CLI command line interface, so terminal command to copy files or blobs to or from a storage account. Now I've got a picture here of One Direction because it's one directional. It's like it. Storage Explorer is a GUI to manage files and blobs, so upload, download or move between storage accounts. And finally we have File Sync. So it's a centralized place for file shares. It uses any protocol. It globally has caching locally. It facilitates cloud tiering. And if a local server fails, it can just easily replace it with a new instance. Now here, there's two one directions because it is bidirectional. Look at Cloud Consultant, and today it's episode 8 of our AZ-900 study cram. It's the first unit of identity and access and security. So first things first, it's going to be Active Directory Services. Basically we're going to talk about Entra ID. What is Entra ID? So Entra ID, or Active Directory Services, is essentially an IAM service, which is an identity and access management service. Access, two things, and identities are what it controls such that you can have one identity which has access to multiple things. That's a kind of fundamental basis. And so Entra ID is the Active Directory in the cloud. So we'll look at these first and we'll come over to that. So what is it? Or what does it offer? Authentication, so self-service password resets. MFA, which is multi-factor authentication. So when you'd have a password, say, and a code to your phone, so it's multi-factor. Custom list of banned passwords and smart lockout services. It also provides single sign-on, so this is where you can have like one username and password for multiple apps, leveraging a single identity, and that then reduces access modifications since you're tied to one identity. So instead of having to manage loads of usernames and passwords for loads of stuff, the admin can just manage your identity. For example, if you roll off a project, kill the identity instead of having to find you everywhere. Next up, app management. So it has features such as app proxy, which is accessing on-prem securely from outside your corporate network. SaaS apps that integrate seamlessly with O365, which is Office 365. Single sign-on, and then My Apps Portal, which is this here. Basically, you can log in, have a screen of apps, and then you can select from them. So this is what enterprises and stuff would use. So you can get access to the various softwares you need just through your one identity. It also has device management services. So you can manage devices just like users, meaning you can restrict certain devices, for example. And devices can be managed through tools like Intune. So who would use Entra ID? Well, IT admins for access control, app developers for when they want signing into their app, so using SSO. Users will password reset, they'll be using Entra ID services for that. And then online service subscribers, if you're using Office 365 and you're controlling access, Entra. So this part up here is that Entra, being in the cloud, it monitors sign-in attempts. However, the on-prem version, i.e. just Active Directory, doesn't. And to connect them together, so you had an on-prem Active Directory and you want to use Entra, you can connect them using this thing here called an Entra Connect, meaning you can sign on here and you can access here. So that's Entra. Now let's look at Entra Domain Services. So Entra ID is you're looking at users, whereas Entra Domain, you can imagine you're now looking at servers, for example, and joining servers to domains, things like that. Because if you think about it, like one website could be run on multiple computers, so multiple machines would have to join the domain. So you want to manage the different servers. So the services which domain services provides, we'll get onto in a moment, but first let's look at this point here. Domain services without need to deploy, manage or patch domain controls. Traditionally, if you have domain services, you would have a domain controller. Now a domain controller is a server in a network that manages security and access to resources through Active Directory. So you don't need this anymore because you can use the cloud version. And so its focus is in managing servers, virtual machines and legacy apps that are traditionally connected to a Windows domain. What does connected to a Windows domain mean? Well, it means that a computer, server or other network device is joined to a centralized network managed by Windows Server using Active Directory. This then allows you to use multiple servers to run one app, for instance, right? And so the services that it provides to do this, or examples of services it provides, is domain joins. This is adding servers on to a specific domain such that they can be used for one app, multiple servers. Group policy, and this is enabling centralized management of security and settings across domain joined devices, so across multiple servers that are domain joined. LDAP provides a protocol for applications to query and manage directory information, so if they want user details, for example. And then Kerberos/NTLM authentication. This offers secure authentication methods to verify user identities, so another authentication service essentially. And so this domain services is good if you want to run legacy apps in the cloud, because if you read this here, allows organizations to seamlessly migrate on-prem applications to Azure by enabling users to log in with existing credentials and manage access using current user accounts and groups. So basically, you can just move your normal stuff where you'd have like this domain controllers and stuff. All those services can be provided in the cloud. How? You get a unique namespace, which is a DNS. And the way that this works within Azure is that within a region, you'll have a replica set of domain controllers, meaning you'll have the exact same domain controller replicated twice for high availability. Now, how is this information then synced up? Well, we zoom in here, you can see you have your on-prem Active Directory, and then here you have your Azure AD tenant, which is your Entra, and in the back here you have your managed domain. And so there's a two-way sync between Entra and your on-prem to make sure that this is always the same. So it's syncing up users, groups, passwords, SIDs, and to Azure Active Directory. Whereas here, so these two sync together, but only Entra calls back to the managed domain to automatically background sync the data that it's got, so that your on-prem is only ever talking to this Entra, and then the Entra talks to the managed domain. And so that, in a nutshell, is everything you need to know for Entra for AZ-900. Look at Cloud Consultant. Welcome back, episode 9, and today we're going to cover authentication methods and external identities within identity access and security. So within here, this is split into 3 parts. We have Entra, which I've covered in episode 8, you can go check that out. Then we'll have this 9, and then 10 will be the rest of identity access and security. So, authentication methods. I've got here a picture of a passport, because that's like an authentication method to show who you are. And so, authentication methods come in a quadrant here essentially. They lie somewhere in here between inconvenient, and high security and low security. The example here is that passwords are the worst, because although they are convenient, apparently, I would argue, not very convenient because you always forget, they're also low security, because there's only one hurdle for the criminal to get your password. They just have to figure that out, and that's you. Whereas, for example, here, it's more inconvenient to have passwords and 2FA, so MFA, multi-factor authentication, where you would have, say, a password and a code, because the convenience factors and the security risks are there for passwords, but then you have an extra layer of security, a second hurdle, which is a code, say, to your phone, which does make it inconvenient, however, makes it much more secure. Next up, we have passwordless authentication, which we'll get to in a moment, which is the highest security, or kind of on par with password and 2FA, but is the most convenient because you don't need your password. So, what does it mean to have passwordless authentication? Let's get to that in a moment. Spoilers, don't look down there. So, first of all, we have SSO, single sign-on. Well, this is where you can have one identity, which you can then leverage to access multiple apps. If you've seen the Entra ID video, you can see that this is an example of an app management. So you can log in once, and then you have all these apps that you can then access from it, which is very common in enterprises. Next up, we have here MFA. Now, this signals portion we'll talk more about in the following episode. We'll talk about conditional access. But essentially, based on a variety of factors, it can request whether you want MFA or not. For example, you can go on a website and then say, remember me for 14 days, and it won't try to MFA. In that case, it would do the allow access route. but generally it would require MFA. MFA being, as we said, getting like a code to your phone or a code from like the Authenticator app. Now the third one, passwordlessness. No passwords. What's it called? Passwordless. Passwordlessness. So anyway, no passwords. So what does that even mean? Well, it can be like biometric data. So for example, your fingerprint, it's not a password, but it's identification. Your face, not a password, but it's identification, for example. So the three suggested ways from Microsoft for this, or talked about ways, are Windows Hello for Business. So this would be where you can use biometric or PIN data, which is then tied to your PC for an extra layer of security. You can also use the Authenticator app. So instead of having a password, you can just use this code. And then finally, you can have fast identity online security keys. So FIDO2 security keys. Here's an example here, which is a YubiKey, which is a USB one. Plug it in, but it can be Bluetooth or NFC, which is like your contactless credit card. It doesn't matter. Essentially, just so some way to have a physical device, then let you know that I am who I say I am. So a method of authentication. Next up, external identities. So for B2B or B2C, which is business to business or business to consumer, you can leverage external identities. So this is, as you can see here, for example, using a Facebook account or a Google account or some Active Directory Entra ID account or something. You can use partners, vendors, suppliers or other collaborators to initialize some self-service sign-up. Basically like a kind of single sign-on. So instead of using a username and password which is within Active Directory, you can then use a trusted parties one. For example, Google's a very common one. You'll see this when you log out of websites and it'll say like, do you want to sign up with your username and email? And you're like, no way mate, but I'll give you my Google because I don't want to deal with another password. So securely interact with your users outside your org, so customers, vendors, suppliers, etc. You can ask the guests themselves or a decision maker to participate in access reviews and rectify or attest to the guest's access. So you can continually review access to see who has actually got it and who should have it or shouldn't have it. And so basically what this allows you to do is to have, say, for instance, B2B collaboration. You could have a company who don't leverage Azure products all sign in with their Google accounts using this external identities. You also get B2B direct connect, so you can, with another Entra org, you can use like Teams shared channels. So if that's another organization who's leveraging Entra ID, you can then use that external identity. Welcome back, look at Cloud Consultant, and today it's the third and final episode of Identity Access and Security, episode 10 of our Azure AZ-900 Fundamentals Study Cram. Let's get into it. So, first things first. Conditional access. So it's an Entra ID tool. Basically, as we've talked about previously in multi-factor authentication, sometimes you can say, remember this device for 14 days. So it won't ask you for the second code. Sometimes not even for the password. And the way that it does this kind of thing is it gets signals, whether that's where you are, the way you've gotten to the website, or something. It then makes a decision based on this. So how risky is this? Is this likely? So if you're on a device and your device has in the same location, it's got the same IP address as the last time it was there, for example, and you're coming in the same way, i.e. through browser, then probably you. But if it's the same device but it's a completely different IP and this time you're coming in via a different method, might not be you. And then it enforces it based on that. So it's useful for requiring MFA, requiring access services only through approved client apps, requiring users to access apps from managed devices only, so like only your laptop for work, not your phone, and then blocking access from untrusted sources. So if you know like specific IP address, probably going to be dodgy, you can use that in a signal, block it, don't let them in. Next up, RBAC, role-based access control. So this is essentially where you will be assigned a role, so it's role-based, and it's access control, so it's controlling your access to something. So this role-based access control is applied to a scope, which is a set of resources or a resource that the access is applied to. here, for example, if we scroll in, you can see here's the standard roles in Azure, and here's your scopes. So you can see here for your role that really for a resource, it should only be to automate processes. You shouldn't be assigning people roles for singular resources. You don't really need to know this for AZ-900, but it's just good to know. Whereas for the other three, management group, subscription, and resource group, reader, observer, you're reading. Admin is the owner, they can do everything. And then all that in between is a variety of users who are managing the resources and using them. So, Azure RBAC, role-based access control, is enforced on any action that's initiated against an Azure resource that passes through Azure Resource Manager, which we'll get to in a way later episode, but Azure Resource Manager essentially manages resources. And whenever you interact with a resource, it's gone through Azure Resource Manager. Meaning every time you try to do anything to any resource, a role will be enforced, or a role RBAC will be enforced. So, next up, Zero Trust model. Secure assets where they are with zero trust. So this is an approach to security where you may have heard before of grant the access of least privilege, something like that, which is essentially saying give people only what they need. So if we go back to like here, if you have someone who's an observer, don't go, well, in future they might need access, so we'll give them one of these. Or, they might, need to add a mate in a couple of months, so we'll make them admin. Absolutely not. Terrible way to do it. So, zero trust is actually a layer above or below. It's a layer more intense in which you're saying, let's just assume everything's going to go wrong and that there's always going to be a breach. So as you can see here, guiding principles, assume breach. And so you're going to minimize the blast radius, i.e. if you're doing RBAC and you have role-based access control, you make sure that the role the person has a tiny radius, meaning you want to be applying roles as low here as you can, so like at the resource group level. For instance, you don't want to be like, they'll probably need access to stuff, let's give them the whole subscription. Not a good way to do it, because if someone then gets access to that who shouldn't, they have more access than they should. And then use least privilege access principle, as we said, and verify explicitly, so always authenticate and authorize based on all available data points. Next up, we have defense in depth, which is an approach of securing every layer, every conceivable layer within Azure that you're leveraging. For example, physical security, that's just securing your devices that you use to access Azure, for example. Identity and access, so that's you want to use single sign-on, MFA. The perimeter, so this is like your DDoS protection, which is distributed denial of service. It's a kind of attack where people would use bots to pretend there's loads of people, say, visiting your website, just so that the channel which lets users in to come see your website gets blocked because there's too many people, essentially. You can imagine it that way. Network, deny everything by default and have a secure connection between on-prem and Azure. Compute, secure access to your VMs, implement an endpoint protection, keep systems patched, meaning keep essentially your operating systems up to date, make sure that everything is secure as it can be. Application, store secrets securely, so using like Key Vault instead of having like your passwords in plain text, for example. And make security a design requirement, so when you're designing the app, make sure security is first and foremost. And finally, data. They're after databases, disks, and they're also after the things which are in SaaS products, which you might not even consider. For example, your Gmail is probably tied to your Google Drive. Meaning, if you have data in your Google Drive and someone accesses your email, not only do they have access to your emails, which then are probably linked to websites and where you have your bank cards leaked, you're going to get in trouble there. But you're also then going to have your Google Drive. So not to scare you, but this is why you need to be super secure. And then cloud storage with Google Drive. But SaaS was more pertaining to, say, PowerPoint or something, right? So as you can see here, when you have gone in at this zero trust idea, using roles for each layer here, like suddenly you have stacks, meaning if someone, say, breaks into physical security somehow to get your laptop, they still have to go through all of these to get the data, because the data is what they're after. Because think about it, even your bank card, the numbers of the data. So anyway, finally, we have Microsoft Defender for cloud. Protection everywhere. So this facilitates or gives protection for Azure native protections, PASS, so it detects threats and anomalies on platforms, data services, it can classify SQL data, assess for vulnerabilities across SQL and storage accounts, and then networks, just-in-time VM access, and set access policies, including for a limited time. It can also protect hybrid resources, so that's some on-prem, some in Azure, as well as other clouds. The thing to note here is when it's leveraging other clouds, so say like AWS or GCP, let's just go with AWS, it leverages AWS's security guidance. And for that, you can see it via the CSPM, which is the Cloud Security Posture Management, and the Asset Inventory page. Now, it works on this idea of continuously assessing, securing, and defending. So, continual assessing is vulnerability assessments, essentially, and Defender for endpoints. So, it's just continually looking for it. It's then securing, which is hardening your resources and services with Azure Security Benchmark. We'll get into that in a second. And finally, defending. So, detecting and resolving the threats. So, advanced threat protection and security alerts, for example. So within Secure, we have this here, which would show you, if we zoom in, you can see it shows you like a score, it shows you different controls, remediations, so one which has been completed, 38 completed recommendations, and then a general resource health. So this is what you'd see if you were using the Defender for Cloud. And what this here actually means is, we'll move it over. Your secure score is a reflection. Your secure score is a reflection of how well you're meeting the Azure Security Benchmark, which is implemented through security policies. And these policies lead to recommendations when resources don't meet the standards. So basically, you have a list of policies saying, I want to have this level of security, say, and then Defender for Cloud will check that against your resources and then give you a score based on that. So, I know that's a pretty heavy one because, cybersecurity and that, but that's us finished, identity, access and security. Come back next time where we will jump into the final module, management and governance. Welcome back. Look at Cloud Consultant, and today it's episode 11 of our AZ-900 study cram. It's our first episode of the final module, management and governance. So, management and governance. What we're going to look at first. Cost management. So, what affects costs in Azure? Well, the resource type. So, for instance, you'll get different sized virtual machines, the same way you would have different sized laptops to buy, right? As we can see if we zoom in here, when you create a virtual machine, you get a variety of sizes, for example. And also for like data storage, you can have access tiers, so like hot or cool, for example, which will change the price because it changes how fast you're able to access the data. Also, consumption, so are you pay-as-you-go or are you a contract? So do you just pay for what you use, which is pay-as-you-go, or do you have a contract to say, actually, I'm going to dedicate myself to having a set number of resources, so say 100 virtual machines for the next 3 years, because some companies require that, say for the compliance and stuff. Next up, maintaining resources. So when you spin up a VM and you put it in a virtual network, blah, 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 you have to maintain the other resources when you delete the virtual machine. If you leave them running, it'll affect your costs. Geography. So labour cost could affect it. So data centres in different regions can cost different prices. And then also the distance to move the data. So if you're moving it, say, from one side of the world to the other, it's going to cost more than if you're moving it from, say, London to France. It's going to be much cheaper than, say, Australia to New York. Now, also, if you're moving into Azure, it can sometimes be free. So if you're moving data into Azure, sometimes free. But if you move it out of Azure, it will be based on the billing zone that it has to go through or has to go in or out. Next up, subscription type. You might have a free tier subscription. And finally, marketplace. So if you're going to use some pre-made services on the Azure marketplace by third-party vendors, then that'll cost you whatever the price is that they give it at. So for instance here, CIS benchmark L1 on Windows, 2 cents an hour. Whereas other things you can see are free, price varies, free, blah blah blah. So next up, how do you calculate the cost then? Well, we have a pricing calculator and we have a total cost of ownership calculator. The pricing calculator is for provisioning resources. So you would say, if I wanted 10 servers with a specific spec, how much would it cost? Whereas the total cost of ownership is more about what would it cost compared to on-prem, which is here you see, versus on-prem. So you would then estimate how much it actually costs for utilities like electricity and stuff. Whereas in here, you're just seeing in Azure. Here it's Azure versus on-prem. Next up, we have the Microsoft Cost Management tool. So this is where you can manage the costs of Azure. So the first one was saying what affects it, how you calculate it, but then how do you get it when it's actually happening? So, Microsoft Cost Management tool. From here, you can get budget alerts. Now you can set these based on either money. So when you reach £10 in the month or something, $10, which is a normal thing budget you would add if you're just a normal person, not a company. They can be using, 6 figures a month. But you can still have budgets. It can be either that or it can be consumption or size. Once my data is up at like 10 terabytes, I want an alert. Next up, credit alerts. Generally, they're at like 90% and 100%. Now you can get credits when you have like a free tier subscription, but here we're more so referring to credits that you get for organizations with enterprise agreements, because when you agree to move to Azure, you can often be given credits from Azure, and that's from EAs. And so based on that as well, you have, for enterprise agreements, departments, and these departments can have spending quotas, so kind of like quota alerts, almost like budget alerts, but for different departments, so say like different subscriptions. Next up we have tags. So finally, tags is a way to track resources. So you could say tag every resource that you create within your company in your development environment. I could do it look Cloud Consultant. And that way I'm able to see what are all the resources tagged look Cloud Consultant. What are they costing? And so in tags you can save the metadata, so it doesn't have to just be like your name. You could save some specific metadata about the resource. Now when you're managing them, convention and rules can apply via policies. So I could say I don't want, specific words in these tags. And the way you can add tags and update tags is via PowerShell, the CLI, so command line, ARM templates, which we'll get to in a bit, but it's essentially automating provision infrastructure. So instead of clicking through the portal, you can write out a little bit of code. REST API, which is, talking to Azure programmatically, or the portal. And here's examples of tags that people would use. You can read it if you fancy. And that is cost management. Welcome back. Look at Cloud Consultant, and today is episode 12, governance and compliance. So first things first, let's talk about Azure policies. We briefly talked about policies for tags, and we've talked about it a little bit through the fundamentals course. But things to really note about policies. First of all, they're set at each level. They're inherited and they're historical. So say you set a policy at a resource group level for virtual machines, right? It would then mean that that's going to be inherited by all the virtual machines inside that resource group, but also historical virtual machines. So if there already are 10 in there, not only does it apply to the 11th you make, but it also applies to the 10 that are already there. And now policies can be integrated easily into ADO, Azure DevOps. Now a policy can either be an individual policy or an initiative, which is just a group of policy. The example that they give is enable monitoring in Azure Security Center, includes policy definitions for OS vulnerabilities, missing endpoints, etc. So basically, when you enable a specific thing, like enable monitoring, right, that actually is a collection of policies within itself, i.e. an initiative. So when a policy has been applied, say to a resource or a resource group, it will be flagged if it fails that policy, so if it doesn't comply. But one thing that you can do with policies is you can have like an auto-resolve. For example, tags. Say you don't want this word used, instead replace it with this other word, you could then leverage that. Now, within Azure Policy, you have built-in definitions for storage, compute, networking, monitoring, security center. So your kind of basic stuff. So next up, we have Microsoft Purview, which is essentially just a way to govern data, right? That's all you need to know for AZ-900. And it works for SaaS, hybrid, on-prem. There's two main solution areas, risk and compliance and unified data governance. But really you only need to know about unified data governance for AZ-900. Basically here it creates an up-to-date map of your entire data estate, identifies the sensitive data, creates a secure environment for data consumers to find this valuable data that they need from your map, and then generate insights about how this data is used and stored, as well as managing access to it. So basically it's for data governance. That's all you need to know, and part of how it works is by leveraging O365 products such as Teams and Exchange. Next up, we have resource locks. They can either be delete or read only, meaning you can lock it for deletion, which means it can't be deleted, but it can be read and changed, or read only, meaning it can be only read, nothing else. Now, why would you want to do that? Because you don't want to accidentally delete it, or you don't want people to be able to modify it, etc. Now, this lock can be removed if you have the privileges, leveraging RBAC, so if you have the right role, you can then remove the lock, make the changes, and then add it or not back on. Next up, we have the Service Trust Portal. Now, on the Service Trust Portal, you get in it using your Entra org account, so your Microsoft Cloud Services account. It provides access to various content, tools, and other resources about Microsoft security, privacy, and compliance and practices. On the main menu, you get the Service Trust Portal, My Library, and then All Documents. So if we look at here what it would look like, basically you come in and you have, see, Service Trust Portal, My Library, All Documents, and then you can pin them and they'll stay in your library. But basically, as it says, learn how Microsoft Cloud Services protect your data and how you can manage cloud data security and compliance for your organization. So it's just for documentation. Look at Cloud Consultant. Welcome to episode 13, Managing and Deploying Resources. So first things first, we have interactions with Azure. So you can interact, as you will recall from one of our earlier episodes, manageability. So in the cloud, we have these various ways to manage it. CLI, API, PowerShell, Web Portal. The portal is your UI. PowerShell is kind of like using a command line interface mixed with an API. It's called PowerShell. You then have your API, which is basically like code which talks to Azure. Or you can have your CLI, which is like running a computer or interfacing with a computer without having all the fancy clicking about. So a CLI is like what you'd imagine a user interface to be for a computer if there was none of this nice graphics that we can see on screen. So let's go back up to here. So as you can see, CLI, Web Portal, PowerShell, but also Cloud Shell. So as you can see here, if you zoom in, we have this which looks like a command line. That is Cloud Shell, which is essentially PowerShell but directly in Azure. I think the benefit here is that you don't have to log in or anything. You're just automatically there. So when you're in a resource group looking at things and you open up Cloud Shell, you're already there. Now, PowerShell and Cloud Shell, they run commands called commandlets, which use the Azure REST API. So essentially it is using the API, but it's leveraging this, it's like a CLI plus the API. Now, using commandlets, you can then save these like as files, so like a PowerShell script, for example, which makes them repeatable and automatable. Remember that, because we'll get onto that in a moment. But basically, it allows you to save the commands that you want to run. So say you want to look at all the virtual machines and update their tags, you could save these to do that. Now, if you're thinking, right, I could update the tags, what about for virtual machines? What if I want to keep making the virtual machine? Well, we'll get to that in a minute when we go over here. But first, we have to look at a thing called Azure Arc. So we're looking now at Azure Resource Manager, which I touched on briefly before, but it's essentially the thing you have to go through to interact with any resources. As you can see here, you have the portal, PowerShell, CLI, REST API. Now, all of this stuff comes into the Azure Resource Manager, which makes sure that you're authenticated, then allows you to interact with the resources. So we have a thing here called Azure Arc. Now, Azure Arc extends your Azure compliance and monitoring to your hybrid and multi-cloud configurations. Outside of Azure, it allows you to manage servers, Kubernetes clusters, Azure data services, SQL servers, and virtual machines in preview. But essentially, it allows you to monitor your services, you can see here, that are, say, on-prem or in another cloud. But anyway, back to the Azure, that is part of Azure Resource Manager, but back to this automation idea, is that if we can automatically manipulate resources, could we automatically deploy resources? The answer is yes. Now, I do have videos on the channel where I teach you how to do this with Terraform, because Terraform is a language you can write which will do the automation of deployment, and it's not just for Azure. It works with AWS, it works with Google Cloud Platform, etc. Whereas the ones we're going to talk about today work only for Azure. That's why they're in the certification. So if we zoom in here, we can see there's a thing called Azure Bicep. It's quite funny how it's worded here. You have your Azure Bicep file where you write code to deploy resources. So you're like, I want a virtual machine that looks like this, I want a virtual network that looks like this, blah, blah, blah. And then that will compile, meaning the file will then get run and turned into ARM templates, which is an Azure Resource Manager template. And this Azure Resource Manager template will then go through Azure Resource Manager and create the relevant resources. Now, you can write ARM templates from scratch, but they are a little bit more complicated and not as nice as using Bicep. But yeah, it's pretty funny. It's called an ARM template and Bicep because it's the good looking bit of the ARM in it, probably. So anyway, the benefits of this is repeatability. So once you've written this Azure Bicep file, you can use that to deploy the same resources every time you run the file. Orchestration, and then modularity. So you can write the code in such a way that if you were to make loads of virtual machines and loads of network stuff, you could compartmentalize them properly such that you can repeat one bit of code by, or not repeat one bit of code by calling to it using modules, for example. So anyway, that's a bit more advanced than you need to know, but you just need to know that you have Bicep, which is a JSON file, which is I suppose I can show you here. JSON format, which just kind of looks like this, and so you would like call something, and then it's kind of like a key value pair, it can be called, which is essentially you have this key which is volume, and then that's the name of the thing blaring. Current is blah blah blah, right? So it just looks like this, but you only need to know that it is JSON, and so you write this JSON, which then can be turned into ARM template JSON, which then goes into the ARM, and then you have your resources at the end. Welcome back, look at Cloud Consultant, and today it is our final episode, episode 14 of the AZ-900 study cram. We're going to cover monitoring, which is always left till last, which is funny because you should be monitoring your resources, it shouldn't be left till last. But anyway, first things first, for monitoring we have Azure Advisor. So if we look in here, we have 5 main categories, which you'll probably need to know for the exam. Reliability, security, performance, operational excellence, and cost. And now you can see here, this is what your advisor would look like. It basically kind of advises you on things, gives you recommendations on how to improve across these 5 categories. And as you can see here, it evaluates your Azure resources and makes recommendations to help improve reliability, security, performance, achieve operational excellence, and reduce costs. And you can access this data via the portal, via the API, and you can get notifications. So if you get a recommendation, you can get notified. You also get Azure Service Health, and so this helps you keep track of your Azure resources, both your specifically deployed resources and the overall status of Azure. So what it does is it combines the Azure status, so how is Azure as a service, like the whole of Azure, then how is the specific services within Azure, i.e. is there something going wrong with how virtual machines are being implemented across Azure? And then the resource health, which is like your actual virtual machine, for example, so it actually impacts you. And for this, using the Azure Service Health, you do get real-time data, but you also get historic data, so you can look at trends, say for your own resources, if they keep going down, for example. And finally, you have Azure Monitor. So Azure Monitor is a platform which has log analytics, which lets you query your logs, monitoring alerts, so if something happens, you can get told about it, and then application insights. So this can be via SDK, so software development kit, or via agent. Now you can read here more about application insights, blah blah blah, if you want. But essentially, it just helps you monitor the performance of your application, and that is it. That is AZ-900 Fundamentals. I hope you enjoyed. If you did, please leave a like, leave comments, questions, queries, and anything more you want to see from the channel. Hope you enjoyed. Take care, and I'll see you later.